These are the frequently asked questions for pre-calculus for section 3.5, day 1. We have an exercises 25 to 38. Solve each equation by the method of your choice. Support your solution by a second method. Not necessarily needing a second method here, but I do want to see that you're able to get these solved. So with number 29, we have 2 to the x minus 2 to the negative x all over 3 equals 4. And hopefully you were thinking right away, well, no, I don't want to work with fractions. I'm going to go ahead and multiply both sides by 3 or cross multiply, make this a proportion. And you'll get 2 to the x minus 2 to the negative x equals 12, which you should notice, wait a minute, this is not simplified. It has a negative exponent. So this would really be 2 to the x minus 1 over 2 to the x equals 12. And with numbers, this is a little bit weird, but you need to think of that 2 to the x just like we would an e to the x. Next step here would be to get rid of that fraction that we have down here, that denominator, and that would mean multiplying everything in this equation by 2 to the x. So if we have 2 to the x times 2 to the x, we have the same base, and we need to add the exponents, and that will give us 2x. And then for the middle term, it's the whole reason we multiplied by 2 to the x, that's going to cancel out. But then we're still going to have a 12 times 2 to the x on the other side, because what we do to one side, we have to do to the other. So now, things are looking a little weird, but I start thinking about that e to the x pattern that we had in class, and I look at this and I notice, hey, this is a quadratic. I have a squared term, I have an x to the first term, and I have a constant. I'm going to get all of that over on one side, and I'm going to make it look like a quadratic so that you can see this. And now when it's written this way, you can see we have something squared minus, and then we have something to the first power, and then we have a constant. So this is, even though it doesn't look like it, very much like the problem that we did in class where we said, you know what? We don't want to work with that all the way through. We're going to make that e to the x and have w substituted in for it. But this time we're going to substitute in a 2 to the x for w. So this will be w squared minus 12w minus 1 equals 0. And we would try factoring first, but there are not two numbers that multiply to negative 1 and add to negative 12. So we'll do this one by completing the square. We'll go ahead and move the 1 over by adding 1 to both sides. And then our b value is negative 12. Negative 12 divided by 2 is negative 6, and negative 6 squared is 36. And what we do to one side, we have to do to the other. So this is now a perfect square binomial, and we will factor it as such. And we have 37. Now I want to get this to say w equals something, because in the back of my mind I still have that I have to substitute that 2 to the x back in there. So we would take the square root of both sides and get w minus 6 equals plus or minus the square root of 37. And then by adding 6, we get this. So now, there we go. Now I start thinking, are those both usable? You know, if I'm going to put w back in there and set this equal to 2 to the x, are both of those usable? So let's get that set up. If we substitute our 2 to the x back in, we realize we're going to end up taking the natural log of both sides. So we'll have the natural log of 2 to the x equals the natural log of 6 plus or minus the square root of 37. And we need to think for a second. When we do that, this x is going to come forward, so x natural log of 2. But on the right-hand side, the square root of 37 is a little more than 6. So 6 minus the square root of 37, that's going to be something negative. And we can't evaluate the natural logarithm of something negative. So I'm not even going to take that plus or minus with anymore. I'm just going to have that be 6 plus the square root of 37, because the other solution was extraneous. And then we go ahead and divide both sides by the natural log of 2, and this just becomes something you very carefully punch in. If you want to punch it in all at once, then you're going to need those extra parentheses when you punch it in. So do that very carefully, and that will come out to approximately, so x is approximately 3.5949 for that one. So a little different look, and that e to the x piece did not come to us right away, and neither would this one. So you have to catch the fact that this is a quadratic that you're working with and go after it that way. Number 30, very similar problem. So 30 is 2 to the x plus 2 to the negative x over 2 equals 3. I'm going to go ahead and work through this one, but I'm guessing since I did the last one, you probably already are working ahead on this one. So let's multiply both sides by 2 and get rid of the fraction there. But while I'm at it, I'm going to go ahead and rewrite that 2 to the negative x as 1 over 2 to the x. And again, just like last time, we're going to go ahead and multiply everything by 2 to the x to get rid of that denominator of 2 to the x. And of course, 2 to the x times 2 to the x, we have the same base, so we add the exponents, and x plus x is 2x. We'll have a 1 in the middle because the 2x's will cancel out, and we'll have 6 times 2 to the x. All right, next thing to do is to realize this is something squared. This is something to the first power, so we are really looking at a quadratic. So I'm going to go ahead and move the 6 times 2 to the x term over. And once again, it just looks completely complicated as long as we leave that 2 to the x in there. So we're going to go ahead and make w equal 2 to the x. And this will be w squared minus 6w plus 1 equals 0. Again, not factorable. There are not two numbers that multiply to 1 and add to negative 6. So we will complete the square. And we have a negative 6 in the b position. B divided by 2 will be negative 3. Negative 3 squared is 9. So we'll add 9 to both sides. That makes this a perfect square trinomial. And we have w minus 3 squared equals 8. Square root both sides, and w minus 3 equals plus or minus. And I'm going to go ahead and simplify that to 2 square roots of 2. And then we add the 3 to both sides. And finally, we will substitute back in. I mean, the whole reason we did this was to make it easier to work with, but we do know that w equals 2 to the x. So 2 to the x equals 3 plus or minus 2 square roots of 2. And we know to use the natural logarithm, so that's why I left myself a little space here. And when we do this, this x that is a power becomes multiplication. And then we'll divide both sides by the natural log of 2. And again, we would test this out and see 3 minus the square root of 8, which is minus 2 square roots of 2, whether or not that comes out to be something that's positive or negative. And this time, they both work because they are both positive. So you'll have to punch in the natural log of 3 plus 2 square roots of 2 over the natural log of 2, and then the natural log of 3 minus the 2 square roots of 2 over the natural log of 2. And that comes out to 2.5431, and change that to approximately since we're doing some rounding here. And approximately negative 2.5431. Or you could put plus and minus 2.5431. So a couple of very similar problems to what we do, in fact, in the next ones. So 31, this is more like what we had in your notes, e to the x plus e to the negative x over 2 equals 4. So we would multiply both sides by 2. And you're going to find that all of the questions that you asked me about, except for number 34, they're all the same type of pattern where we're doing a little substitution to get rid of the things that are ugly, the things that we'd rather not work with. So now we look at this and we say, wait a minute, they left a negative there. That is not cool. You can't do that. You're supposed to simplify them. And now we have a fraction which we would rather not work with, so we're going to multiply everything by e to the x, and that'll give us e to the 2x plus 1, because these will cancel, equals 8e to the x. And again, we see that we have a squared term and we have a first power term, so e to the 2x, subtract the 8e to the x from both sides. And we're in the position of not wanting all of that. We're going to go ahead and use e to the x as our w for substitution right there. So now we'll go back and make it w's. We will hope that it is factorable, but we see again it is not. There are not two numbers that multiply to 1 and add to -8. So a quick little completing the square will be just fine. Move that 1 out of the way. -8 divided by 2 is going to be -4, and -4 squared is going to be 16. So we're going to add 16 to both sides. That gives us a perfect square trinomial of w minus 4, the quantity squared. Square root that bugger, so y minus 4 equals plus or minus the square root of 15, and add 4. But the whole reason we did this, we had this nasty little w equals e to the x up here. So now at the very end, we bring that back into the picture. And we realize to get rid of the e, we'll have to take natural log. So this will drop right out and we will get x equals the natural log of 4 plus or minus the square root of 15. And again, to tell whether or not we can use both of those or if one is extraneous, you'd have to figure out that, hey, the square root of 15 is going to be a little smaller than 4. So even when we subtract that, we will get a couple of positives. And then you punch that in and we get approximately plus or minus 2.0634 when we do that. So all about that little substitution piece, you know, that it just makes it so much easier to work with, taking out something that is difficult to work with. And in 32, we have a very similar situation. We can see that we have something squared, something to the first, and then a constant, so we are working with a quadratic here. And what we want to do, if we can, is we want to factor this. So I start thinking, all right, I'm going to put a w in there. We wouldn't necessarily have to with this one because it is factorable, but I think you'll be able to see it easier if I make w e to the x. So 2w squared plus 5w minus 3 equals 0. And then we finally have one here that's factorable. So we have a 2w and a w to give us 2w squared. In the back, we need two numbers that multiply to -3 and somehow add to 5. So if we put a -3 in this position and a +1 in this position, outside times outside will be -6w, and inside times inside will be a positive. So we realize, wait a minute, we need to switch those signs there. But at least that helps you by just putting them in. That helps you think through, okay, the 3 was right, but the sign wasn't, you know, and you can go from there. Otherwise, we backtrack and go back to, we have two numbers in front that multiply to 2, two numbers in back that multiply to 3, and go outside times outside plus inside times inside until we manage to find it, and then front, front, last, and last. Either way, as long as you can get there, that's what I care about. So if we were to solve this quadratic, we'd say 2w minus 1 equals 0. We'd add 1 and divide by 2. And we'd say w equals -3 for this one, because w plus 3 equals 0 would mean we'd subtract 3 from both sides. So then we check to see, what is this going to do when we put our e to the x back in here? So we would have e to the x equals 1/2 and e to the x equals -3. Well, this one, hopefully you notice right away, that's going to be undefined, because with e, we'll need to take the natural logarithm of both sides, and we would be saying that we're going to take the natural logarithm of a negative number, which we cannot do. It is not in the domain. This little bugger is gone over here. And we have x equals the natural log of 1/2, so x is approximately negative 0.6931. So that one was set up a little bit nicer, but again, that substitution makes it a little easier to see what's going on. We certainly can factor with that e to the x in there, but if you weren't able to see it, I wanted to make sure that it was very clear. Then, number 34, this is a logistical equation. And these are the ones that we solved algebraically earlier on in the chapter. And what we decided was, hey, this is slap a 1 under here. Let's make a proportion and make this a little easier. Proportion, we're just going to cross multiply. So we will get 400 times 1 is 400, and 150 times 1 plus 95, e to the negative 0.6x. Then, to get rid of the 150, we would divide both sides by 150, and you do a little reducing there, and we get 8/3 equals 1 plus 95, e to the negative 0.6x. Now our job is to get that base of e by itself, so we're going to go ahead and subtract 1 from both sides, and subtracting 1 is the same thing as subtracting a negative 3/3. So we have 5/3 equals 95 e to the negative 0.6x. And normally what we would do is divide both sides by 95, but because we already have a fraction on the other side, let's go ahead and multiply by the reciprocal. And when you do that, I mean, it's not beautiful, but it's not awful either. 1/57th is what we get. Here we have our e to the negative 0.6x. And then e, the base, is exposed. We're going to go ahead and take the natural log of both sides. So the natural log of 1/57th equals our e, I should just cancel that out there, there we go, negative 0.6x, because e and natural log are inverses of each other, and then divide by that negative 0.6, and punch it in. You know, again, if you want to punch it in all at once, make sure you're using parentheses. The calculator doesn't understand that we need to do everything in the numerator before we do any division by the denominator. And that comes out to approximately 6.7384. Beautiful. And that's the end of your list.